into just a little bit a short intermission just so I can grab some water. I will be right back. Oops, wrong screen. All right, I'm back and I'm ready. So we're gonna hop right back into this and go to question number 21. We want to draw the Lewis structure of O2 2 minus. So for this, oxygen is on the 16th column. Being on the 16th column means that you have 6 valence electrons typically. With that being said, it's going to be 12 electrons we're working with, but we also have the +2 here because there's a 2 minus. So we need to work with 14 electrons. So with that being said, we're going to drop both oxygens in the middle. So O, well, not in the middle, oxygens next to each other, O and O. And now we're going to fill in the current, I guess, valence electrons that each has. So B, 1 is right now being shared. So 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And now we can go ahead and add the 2 minus, okay? And now just go with, as we see, the unpaired electrons. 1, 2. Do we have 14 electrons total? We have 6 lone pairs and 1 bond. That is indeed 14 electrons, so that's perfect. Now, that really would be the Lewis structure of oxygen. To further support this and to see how we got that 2 minus, we can actually talk about its formal charge. Oxygen typically likes to have 2 lone pairs and 2 bonds for it to have a formal charge of 0. In this case, 1 bond was replaced by a lone pair. So when that happens, we take a more negative step, a step towards the negative. So each oxygen here had a minus. So as you can see, because these 2 oxygens both had a formal charge of -1, that is how the whole polyatomic ion has a formal charge, well, not formal, has a charge of -2. And that would be the Lewis structure for O2 2 minus. So there you go, the bond, and then they filled it in, and there you see the 2 formal charges. And that would be O2 2 minus. This is correct. So let's move to question number